Good morning, students. I hope all you are well. Today we discuss about partial differential equation of first order. So, first definition. A partial differential equation is a relation between the independent variables, the dependent variable and its partial derivatives. Now, the order of a partial differential equation to be the order of the derivative of highest order occurring in the equation. For example, number 1, x del theta by del x plus y del theta by del y plus theta is equal to 0. We see that here highest time derivative is del theta by del x, which is one time derivative. So, the order of this partial differential equation is 1. So, we can write it as a first order partial differential equation. Number 2 example, del 2 theta del x square is equal to a square del 2 theta del x square. Here we see that highest time derivative is del 2 theta del x square. That means 2 time derivatives. So, here it is a second order partial differential equation. Number 3, del theta by del x whole square plus del theta by del y is equal to 0. We also notice that here highest time derivative is del theta by del x. So, this is also a first order equation where theta is dependent variable and x, y are independent variables. Henceforth, when there are two independent variables, we shall denote them as x and y, whereas dependent variable is denoted by z. There are some usual notations such that small p is equal to del z by del x. That is partial derivative of z with respect to x, treating y as constant. Now, q is equal to del z by del y. That means partial derivative of z with respect to y, treating x as constant. Now, r is equal to del 2z del x square. That is 2 time derivatives of z with respect to x. Small s is equal to del 2z by del x del y. That we can write it as also del x of del z by del y. And last, t is equal to del 2z by del y square. That is 2 time derivatives of z with respect to y. So, we consider the partial differential equation of first order, which in symbolic form can be written as f of x, y, z, p, q is equal to 0. Now, formation of first order partial differential equation. So, first we form by elimination of arbitrary constants. Here is the equation is z is equal to x square plus a into y square plus b. We write this as number 1 equation in which the constant a and b are arbitrary. So, to form the first order partial differential equation, we have to eliminate these arbitrary constants a and b. For this, we differentiating partially with respect to x and y of the given equation, we get del z by del x, that is derivative of z with respect to x, treating y as constant. Here the equation is z is equal to x square plus a into y square plus b. We treat y as a constant. So, y square plus b is unchanged and derivative of x square plus a is 2x. So, del z by del x is equal to 2x into y square plus b. We know that del z by del x is equal to p. So, we write it as p. Del z by del y. Here, del z by del y means derivative of z with respect to y, treating x as constant. So, x square plus a is constant and derivative of y square plus b is 2y. So, del z by del y is equal to 2y x square plus a. We know that del z by del y, we can write it as small q. Now, for eliminating a and b, we product P and Q. So we take product small p into small q is equal to 4xy y square plus b into x square plus a. From 1 we see that this x square plus a into y square plus b is equal to z. So small p into q is equal to 4xyz. Here is some connection. This is a is equal to sign 4xyz, which is the required partial differential equation of first order. Now second number process, elimination of arbitrary function. Now we take the function capital F of u comma v is equal to 0, where capital F is an arbitrary function of u and v, and u and v are known functions of x comma y and z. We know that here z is a dependent variable on x and y, and independent variable is x comma y. So here f of u comma v is equal to 0, we write this as a number 2 equation. Now differentiating number 2 partially with respect to x and y, we get del f by del u bracket del u by del x plus del u by del z into del z by del x plus del f by del v bracket open del v by del x plus del v by del z into del z by del x, where p is equal to del z by del x, and del f by del u bracket open del u by del y plus del u by del z into q plus del f by del v bracket open del v by del y plus del v by del z into del z by del y is equal to 0, where q is equal to del z by del y. Now we eliminate del f by del u and del f by del v from the equations. We write these equations as 3 and 4 from the equations 3 and 4, and we have obtain del u by del x plus del u by del z into p bracket close. Now del v by del y plus del v by del z into q bracket close minus del u by del y plus del u by del z into q bracket close del v by del x plus del v by del z into p bracket close is equal to 0. Now we see that del u by del x into del v by del y plus del u by del z into del v by del y into p plus del u by del x into del v by del z into q plus del u by del z into p del u by del z into q minus del u by del y del v by del x minus del u by del z del v by del x into q minus del u by del y del v by del z into p minus del u by del z del v by del z into pq is equal to 0. Here we cancel this term. We take common p and we take common q. So we can write del u by del z del v by del y minus del u by del y into del v by del z bracket close p plus del u by del x into del v by del z minus del u by del z into del v by del x bracket close q is equal to del u by del y del v by del x minus del u by del x into del v by del y. Now we take minus sign on both sides. So we can write it as del u by del y into del v by del z minus del u by del z into del v by del y into p plus del u by del z into del v by del x minus del u by del x del v by del z bracket close q is equal to del u by del x into del v by del y minus del u by del y into del v by del x. We write it as a equation number 5. Now if we write capital P is equal to del u by del y into del v by del z minus del u by del z into del v by del y, this is equal to del of u comma v by del of y comma z. We take capital Q is equal to del u by del z into del v by del x minus del u by del x into del v by del z equal to del of u comma v divided by del of x comma z. Capital R is equal to del u by del x into del v by del y minus del u by del y into del v by del x is equal to del of u comma v by del of x comma y, where our Jacobian is del of u comma v by del of y comma z is equal to determinate del u by del y, del u by del z, del v by del y, del v by del z. So the equation number 5 can be written as capital P into small q plus capital Q into small q is equal to R, which is the partial differential equation of first order. Now example number 1. Eliminate the function small f from z is equal to e to the power mx f of x plus y. We write this equation as number 7. Here we know that del z by p, small p is equal to del z by del x, and del z by del x means partial derivative of z with respect to x treating y as constant. Here first function is e to the power mx and second function is f of x plus y. So derivative of the first function m e to the power mx, second function unchanged f of x plus y, plus first function unchanged e to the power mx, derivative of the second function f dash x plus y. Small q is equal to del z by del y. That means partial derivative of z with respect to y treating x as constant. So this is equal to e to the power mx f dash x plus y into 1. Now we write small p as equation number 8 and small q as equation number 9. Subtracting the equation 9 from 8, we obtain small p minus q is equal to, one term we cancel, is equal to m e to the power mx f of x plus y is equal to, we put the value from number 7 and we write it as p minus q is equal to small m z, where z is equal to e to the power mx f of x plus y. So we eliminate here the arbitrary function f and we get the required partial differential equation. Example number 2. Form a partial differential equation by eliminating the function small f and g, that means two functions small f and g, from z is equal to f of xy plus g of x by y. Now we write number 10 the given function, that means given equation z is equal to f of xy plus g of x by y. So differentiating the equation number 10 partially with respect to x and y respectively, we get small p, that means del z by del x is equal to y f dash xy plus 1 by y g dash x by y, because we derive with respect to x treating y as constant. Small q is equal to del z by del y, that means partial derivative with respect to y treating x as constant. So this is small q is equal to x f dash xy minus x by y square g dash x by y. Small r is equal to del 2z by del x square, that means 2 times derivatives of z with respect to x. So we derive small p again with respect to x. So we write here this is equal to y square f double dash xy plus 1 by y square g double dash x by y, and t is equal to del 2z by del y square. So we again derive small q with respect to y. So this is equal to x square f double dash xy plus 2 by y cube into x g dash x by y plus x square by y to the power 4 g double dash x by y. Now we are numbering the equation p as number 11 number, q as 12 number, r as 13 number and t as 14 number. Now multiplying equation 11 with x and equation 12 by y and then subtracting, we obtain xp minus yq is equal to 2x by y g dash x by y. And again multiplying number 13 by x square and equation 14 by y square, and then subtracting, we get x square r minus y square t is equal to minus 2xy g dash x by y. We write it as a 16 number equation and xp minus yq as 15 number equation. Now adding 15 and 16, we have x square r minus y square t plus xp minus yq is equal to 0. So we eliminate the arbitrary functions f and g and we get the second order partial differential equation, which is our required.